Hello and welcome back to my channel. I just want to point something out because I end up having to take the panel meters out for a third time because I wanted to put anti-parallel diodes in here. If you can just see down there's a 1N5822. So I already added those two 100 microfarad electrolytics with a 1 microfarad monolithic across the back of them in parallel to the output. Then today I added a 1N5822 in reverse parallel and two 1 microfarad MKT capacitors going to a 100 ohm resistor to ground to shunt away common mode noise. So I just wanted to update you on that. But with that being said, that is now the bottom half of it complete, the chassis, whatever you want to call it. So now we're actually moving on to the boards. So I've already gone over the boards to save some time. This board, everything's good on it. In terms of capacitors, sorry. I have not checked the transistors or the op amps. I have tested every single diode, except for the Zenas. So the things we're going to be looking into will be the op amps, Zener diodes, transistors. There are some capacitors I need to change. So all these 220s surprisingly come in with a good ESR, don't seem to have leakage. I mean, I'm not really passing voltage through them, but still. Yeah, they meet their rating, and they've got a nice low ESR, so I find that kind of amazing considering they're right next to all these resistors that are running that hot. But yeah, I don't know what to say. I guess I'll just move them a bit far back as I can, you know. These 100 mics, these are all gone. These all need to be changed, so I will be changing them. They're not in parallel with these other caps, incidentally. They are for separate things. Now, all of these Sprague capacitors, these ones are Siemens, sorry. So Siemens, Sprague, they're good. These two little 4.7 microfarad ones made by Weimer, these are not, and these Weimer ones are not. So the Weimer ones need to be replaced, but there's only 6 capacitors on here that need to be replaced. And yes, I've checked the two tantalums, they're not shorted. So I'm gonna whip out these caps, change them. I've already got the replacements right here. The ESR on these may not be as low as what these old ones used to be, but that's all I've got lying around. What else was I going to say? Oh, I'm going to go and bring up all the data sheets. I did get all the data sheets of the components last night. So I'll load all that stuff up now. I'll go grab a couple more components. I'll put these capacitors in where these guys were, and then I'll come back and we'll start doing these ones. I'll do these ones on camera too, why not? I just wanted to show you one thing. The capacitors I took off the front panel, I ended up keeping them. I tested them with voltage and they had no leakage. And they also are still at their rated value. They're 100 microfarad caps. They come in about 118, 115 microfarads. And they've got an ESR of 0.4, 0.5 of an ohm with no leakage, and they look perfect. So I will keep these for some old radio or something I want to build where I want to put age appropriate looking components in it. That's something I do. I think I might have mentioned that in the last video, but yeah. These are TL072s. TL072 CPs. Because I'm going to need to change the op amps in here. So, I know I have not 100% decided upon that yet. I still need to look at data sheets. So, I'll do that now and I'll be back in a minute. Alright, so I've gone over what I'm going to do with these boards. Capacitor wise, these are good. These purple looking ones, they're actually perfect. They actually got really good ESR, no leakage. Their values bang on. I'm shocked, I don't know what to say, but anyway. These ones are all ruined. I can't remember if I mentioned this already or not. Sorry if I did. These two little 4.7s are also ruined, so I've got those to replace them. I've got 4 low ESR 100s at 63 volts to replace the 100 at 35s. These older style big capacitors typically have pretty low ESR, that's why I've chosen these. I am going to use the TL072s. Obviously it's a different pin out, so we're going to have to work around that. Make up a little adapter with sockets or something. I'll get to that when we come to it. But it's not going to be too hard. I mean, I basically just have to remove the compensation capacitor, remove the op amp, build a little adapter, and make sure that there's no other external components that are hooked up to them. Like, they've got offset pins on them called balance pins, the LM301s. I don't think any of them are hooked up. From what I've seen so far, there's only one balance pin tied to one end of the compensation capacitor and the other end going to the compensation pin. So, and that's the positive non-inverting balance pin. Yeah, no, they're all left floating the other balance pin. So yeah, looks like it's just remove that, build an adapter, put the adapter in, then put the S72 in place. If I have to adjust stuff afterwards, I will. Anyways, I've got my desoldering gun heated up and I've got my soldering station ready, so I'm going to start removing these two capacitors. Might not even need to flow solder on here, no. Didn't think so. Good old actual solder. Is this capacitor glued down to the board or something? Oh, I see, it's leaked. It's leaked that bad, it's glued itself to the board. I haven't really come across that before. Usually it's like dry and crusty, not like a glue. Although I think I have come across some sticky leaking capacitors. You see that on the board there, that residue? It was kind of stuck to the board. Anyway. You know what, now I think of it, why don't I use the desoldering gun, because I'm going to have to clear the bloody holes out anyway. Where am I? What have I done? I just flipped the board around and lost the capacitor. There it is. Two beautiful clear holes. Well, that's them out. I'll just get rid of this little bit of residue. It's completely dry, it's not eating anything anymore, otherwise I'd be getting the cleaner on it. I might actually just get a bit of IPA on a Q-tip. Yeah, that's better. Beautiful. Okay. Dumbass, I'm gonna have to go look at my video. I just realised this board's not marked. I'm so used to working on new boards where electrolytic capacitors have got, you know, like a negative or little one half the circle's got a black line through it. I've just ripped them out without taking note which way they went in. I'm gonna have to go back through my video. How annoying. How bloody annoying. Oh, God. You know what? I should be able to just plug the power connector in to this board, sit it on my J-Car magazine. Yep, that works, and I should be able to just turn it on and read the voltage across there, and I'll see what polarity it is that way. That way I don't have to stop recording. Sorry about this, guys. Very stupid move. Power on. Where'd the bloody cap come from? Ah, there we go. Across this resistor. There's no voltage on it. I think I have to plug the other connector in. Brilliant. Oh my goodness. Probably is the other board. Wouldn't be surprised. Luckily these things are keyed so I can put them together pretty easily. Might have been quicker to pause the video. The thing is, I don't have video editing software, so if I pause the video, yeah, that was easy to get them together. Easy to get the whole thing back together. Alright, well that's both the boards together and both the edge connectors together, so I'll try again. Right, we have 140 millivolts. It doesn't really make sense. No, the other side's got 827. Let's see if that changes if I turn the voltage up or down or something like that. Ah, there we go. Was the other side the same polarity? Oh wow. Okay, so it's positive on the left. Cool. That saved me some time. Oh, fuck. Oh, excuse me. I just grabbed one of those bloody 1 kilo ohm resistors that I thought were 8 watts, but I think they might be 3 watts. It's really hard to read the package. Fuck, that hurt. Man, that bloody stung. I'm going to get the board out without shorting anything because it's got charged capacitors probably. Right. Yeah, so it's keyed with 1, 2, 3 screws and then all the pins that hold it together. So it's pretty easy for me to just pop it together, stick it in there and turn it on. I've already put everything back together in the bottom end, so that's ready to be powered up. Right, so it's positive that way, so that side's positive. I'll just put a line where negative goes. I can't believe I just did that. If I really wanted to make myself look good, I wouldn't leave that on camera. But it happens to the best of us. Anyone out there that says that they never do the dumbest little mistakes every so often, even though they've been doing this for years, is just lying to you. We all have our dumb days. Me, especially if I'm tired or if my mind's elsewhere, I'll do silly stuff. Which for me is pretty insane, considering I've been playing around with electronics since I was about 6 years old. So if I can do it, anyone can do it. Alright, that's our first two caps. I know that the ones that are in there are axial, and the ones I have are, what do you call them, cylindrical or whatever, not axial. But make and do with what we've got here, guys. It's my own personal power supply anyway. Like I said, that's like those big, well, not so big now, filter caps that I replaced, should I say. You know, like, they're safe. It's not like they can short on anything. If I was going to sell the unit to someone, I'd mount them more securely than just having them cable tied down to the loom, because I wouldn't want it to get knocked in transport and, you know, like, get damaged in there. But it's going to be sitting on my bench, not going anywhere, so I am not concerned about that. Well, that's them. Let's start on these four. There's not a lot to change in terms of capacitors, surprisingly. Well, I just completely destroyed the pad there, but that's fine because I can fix that. I am the trace wizard. I have to do a video on trace repair. Man, I'm really good at like ribbon cables, traces, really small stuff. I've got some really cool techniques. I think I'll make a video on that because I've seen a few other people do videos on it. And I'm not saying that they're not good at it too. I'm just saying that I've only seen videos, like people do a video on how to repair a flex cable or ribbon cable, whatever you know it as, or how to repair PCB traces, or like one specific thing. I'm thinking about doing a video where I just get some circuit boards and different types of ribbon cables and flex connectors and stuff, and show you all different methods all in one video. But yeah, that's just an idea I've got. Just don't press down. If I don't press down too hard, I'm alright, not destroying it. As I just destroyed another one. Yeah, it's not like I'm missing a lot of track either. It's going to be real easy to sort that out, especially with how low current it is too. It's not like I'm worried about it. Probably just blob it over with a bit of solder for effective repair. Okay, I know what I'm going to use. I'm going to use these. The handy thing with this tool is it's got this angle here, so you can grab something and lever it off. Don't go doing that with modern circuit boards. You'll rip plated through holes out and all sorts of stuff. But because the pads are on the bottom only on this board, it's perfectly fine. And the pads are kind of screwed anyway. And even though they're screwed, it hasn't made them any worse. So, not a bad method. So, Oh, I've still got solder on one of those holes somehow. That's a bit odd. Just clean up the bits that I've damaged. Yes, I am deliberately breaking that more. If I rip a trace, I like to clean it all up back to where it's solid on the board, not flaked up and do dodgy, what do you call it, like trying to stick it back down sort of stuff. Those repairs don't last in the future, you know. I don't think I'm going to even need to cut copper tape for these. That one there I might need to lay down a little piece of wire, but the rest of them I'll be able to fold the lead over and just solder it on. And don't worry, I know the polarity of those capacitors. I studied this intensely earlier on. All of these ones, the negatives are on this end, and all the top row, the positives, are on that end. So don't worry about that. Could you imagine if I screwed the same thing up again? Twice. Wouldn't it be good? On camera. I think I'm just going to do one at a time. Particularly where I've buggered the traces, I'll do one at a time. So with that one, all I've got to do is really cut it off and just bend it over what's left of that pad. This one, might be able to actually use that leg and bend it back around. Yep. See? I told you I'm a master at fixing torn traces. Once that's soldered, you'll barely be able to tell it was ever there. Hey, what are you doing? Hey, oh shit! Oh no! Fuck! Excuse me again, my power supply that I'm building, like the one that I've designed myself completely from scratch, get out of here! My cats have literally just started chewing on all the wires and trying to rip me out. Just bent resistors and everything. Oh, far out, I'm sick of this shit. They don't understand. I know they're cats, I know, they're not supposed to understand. Why have you got to destroy my stuff? Come on. Alright, let's go in with the next one. Oh, I put that capacitor in the wrong way around. Why can't I work and talk? You know, if I just shut up, I do really good, but when I'm talking, I just screw up. I don't know what to say. And sometimes I do that, like I've actually caught myself out like on channel here, working, and I've sort of gone quiet and just started working, and then I've been like, oh man, that's not good. Like my audience, you know, I'm just like, what do you call it? Not zoned out, zoned in, like on what I'm doing, and I know that's not good. I'll keep this cap for a different hole. You'll see why in a minute. Because if I turn it around, I won't have enough leg to fold back around and fix that trace. So yeah, negative goes up. Hopefully this is the last time I screw up the polarity of the capacitor. I think I'm just gonna do this and not talk so much. That's what I've got to put on my shopping list for J-Car. Flush cutters. And I was making a list up earlier and I was like, man, there's something I'm forgetting. I just remembered it. Because I'm trying to use these where I would normally be using my flush cutters. Right. This is a tad short, unfortunately. See if I can make use of a little offcut. Yes, that will do quite nicely. Can't get neater than that. One thing a lot of people probably work out after watching my channel is I'm really good at making things work with small spaces, even though I don't use SMD unless I have to. Okay, I'm very happy with that. Sorry, I just realised my head's getting in the way again. Cool. Alright, now I'll put the rest of the capacitors in the right way round. What I'm going to do with those 220s is I'm going to heat up the pads, reflow them, and pull them out as much as I can without it being, you know, a shit connection, and try and bend them even more forwards away from those hot resistors. Obviously I'm not going to change the resistors today because, like I said, I've run out of 2 watt. Wait, right, that's it. Get out. That's not a fucking toilet. Get out. You're not eating my wires, Eva. Get out. Come on. Hurry up. So stressful having cats get into your lab, especially when you got a lab like me. I mean, you guys have seen around my lab. It's pretty intense. There's a lot of stuff in here. Just can't have cats going through it, you know. It's yeah, no can do. All right. Anyway, so yeah, because I can get more space on these and move these forwards like that, I want to move them forwards as much as I can away from this hot area and lift them up off the board. I mean, if it was up to me and I installed them, I would have installed them up higher already, you know. I was just going to say, oh, I should put them on the bottom, but you know, you can't because the board's sandwiched together. That's a shame. That's one thing I like about old school boards, just 1 or 2 layers. You can do stuff like that, you know. If you've got hot components, you can put them on the top, and you can put your capacitors and stuff like that on the bottom so that they're in the cold area. Sort of like how things used to be built in the old days. Not something you see anymore. Go pull apart an old radio from the 60s or the 70s or something like that, and you'll find all the tubes which produce heat, valves, tubes, whatever, they're all on top, and you'll find all the capacitors and everything else, especially temperature sensitive stuff, it's all in the bottom of it. It's funny how all that stuff lasted so long, eh? It's funny how when capacitors were 10 times the size and not mounted in stupid hot places, that they lasted. Like, who would have thought? I really could go on and rant about the way technology's going. I just don't like it. You know what I mean? There's so many things that are great, like the advances in certain components and stuff like that. But the form factors, I don't agree with. I really just think people should just deal with the size and still go a little bit bigger. I don't even hate surface mount, but just really, really small stuff, you know. Once you start going down to 04, 02 and, you know, the ridiculous sizes, I forget what they're all called because I'm not an SMD guy, but you know what I'm talking about. The bits that you can, you know, they're like a microscopic piece. Like, just stick to like 06, 04, 08, 05, all that sort of size range, you know. Use through a hole wherever you can. I don't know why we can't just do the world like that, you know. I think it would be a lot better than what we're doing. But I guess that's just the way it is. No, I don't use a lead former. I just, again, without trying to sound like a cocky prick, it's just something you get used to. When you've been doing this for years, you just get used to just eyeing something up, and you just like, all right, this needs to be that long. You just know, and you just do it by eye. Roll the leads by hand. Anyway. Beautiful. Right. So they're away from the heat as much as possible. See, that's the thing. Design is everything, you know. Just moving that capacitor half a centimetre back and angling them out, they're basically not seeing any of that heat, you know. And these ones, let's see how much I can get the pins out without taking them out the solder. I will come back and reflow these afterwards with solder. Luckily I can still have about 1 millimeter of pin left out the board after I've pulled some out. So we've got a little bit to work with. We can at least stand them, maybe not off the board, but certainly back. Alright, let's see what we've got. Well, they're already about 3 mil off the board. I see that their leads are sort of bent, so I can pull them up and straighten them a bit more. Alright, now how far back can I get them? Now come on guys, you tell me how much of an improvement that is. You saw it before. And don't forget, when I replace these resistors, I've already checked these all out. I think they were 1K. These are all red, 2.2K. They're all still working, so luckily I can put this back together after we get this going. And we can start fixing the amplifier. And if I go to J-Car tomorrow, which I probably will, then we'll do the resistors tomorrow with the op amps. If I don't do the op amps tonight, but they're all good. 2.2, 2.2, 2.3. That one's, yeah, that's really getting burnt up. It'll do for, you know. These ones are, you know what? The amount of heat that comes off of them, I'm just going to go get a 2-watt resistor, what I use. Just a 5% carbon film. I just want to compare the size of it. Because the thing with resistors is not just the wattage rating of the resistor, but the actual size of the body has a massive effect into how much power it can dissipate into the air. Yeah, see, my resistors are bigger. So I'm going to replace it with these, not these particular ones, better ones, but, well no, actually yeah, these particular ones. 2 watt, aren't they? Sorry, I'm just having a look in the J-Car catalogue quickly. Sorry if some of my words are a bit hard to understand. Like I said in one of my videos, I made a lot of dumb decisions earlier in life and I screwed up my teeth. They're only 1 watt apparently. I screwed up my teeth and I need to go get all my teeth fixed, and it kind of messes with my talking. Yeah, I definitely don't have any 2.2Ks. That really sucks. Well, anyways, there's 1K it looks like. I just can't read the band properly because it's burnt. Yeah, 1K. They both come in at exactly 1K, but no, they do get ridiculously hot. And it doesn't look like these bigger ones are actually the source of the heat. It looks like it's only these 1Ks, these 2.2Ks, and these 1Ks, but not that 1K. Yeah, okay, all of the 1Ks. Oh, that's not 1K. What is that? 1.2K? Yeah, 1.2K. You know what I'm tempted to do? Again, it's my supply. I want it to last. I don't want the board getting burnt to the point that it's carbonized and then it's leaking current across stuff. I'm just going to pause the video whilst I look at my resistors for a sec so I don't waste your time. Alright, I've just had a look at my resistors and what I've actually got. I've come up with some ideas. I'm just going to move the camera over here. Oh, I'm about to lose the whole thing. Oh, no. I have to move the clip. Sorry, my apologies. So, I was just having a look at what resistors I actually do have in stock. And it turns out I've actually got a few ideas to really sort out the heat dissipation problems. But one of the main questions I've got is those two 1 kilo ohm resistors, the big green ones that I've burnt myself on. Are they 3 watt or 8 watts? Because it looks like the writing is 8 watts, but from the size of them, I can't understand the 8 watt thing. But from the feel of them, I can. So, what I'm going to do, again, I'm going to put this together, the two boards. We're going to drop it in here. Again, hey man, just give me a sec. No, you're right. I'm in the middle of working on something. I'm doing a YouTube video. Hold on, I'll let you in. I'll be 1 sec. Sorry guys, I've got to pause the video. I'll be back in 10 minutes, but it'll seem like a minute for you. Alright, I'm back. Sorry about that guys. That was my mate. He drives a Ford Falcon, and I always do all the repairs on it. I've actually got 2 guys that I routinely service cars for. Well, you could say 3, you could say 4, but the 4th guy's had an accident, so he doesn't have his car. And the 3rd guy, he sometimes gets me to service it and other times takes it to a mechanic and then goes to the mechanic and then comes back to me and complains about how much the mechanic costs and then gets me to do it a couple of times and then goes back to the mechanic. I can't work him out. Anyway, this guy always gets me to fix his car and service it, so that's good. It's also one of my mates. He didn't stop by because he needs his car service. He stopped by to say hello. But yeah, I'll upload some videos of that because that's actually something else I do quite a lot of. I fix people's bikes, people's cars, appliances, anything really. I do construction work. If someone wants a gutter replaced, I'll do it. If someone wants a fence put up, I'll do it. If someone needs to pave something, I'll do it. If someone wants to rip out their kitchen and put in a new one, I'll do it. Like, yeah. You can say I am a multi-skilled person. Alright. So, what we're going to do here, I'm going to power up. You can see the meter. I'll just show you that these caps have got 30 volts on them and these ones have got 29.87. We powered up. I want to see the voltage across the 1K resistor that's on the... Okay, I had a feeling that's what it was doing. That's the resistor that goes across the capacitor bank straight off the diodes off the transformer. Okay, so that's got 56 volts on it. Let's go to a voltage, amperage, wattage calculator because I am a lazy shit and cannot be bothered to learn the formulas when I can just type them in. 1000 ohms with a voltage of say 57. That's 3.249 watts. And well, yeah, actually that's got 3 written on it, and that looks like an 8. But, well, they're running over 3, so you know what I'm going to do? Pause the video, I'll be back. Five watts, 1 kilo ohm. So I'm going to change those. That will allow me to get them a bit higher off the board, and the bigger package size won't get so hot because it'll be able to dissipate the heat into the air more efficiently, which also won't cook the capacitors around it as much. Yay. Those are 1Ks that get hot too, that's right. Those have only got 20 volts across them. Let's do the math on that. Okay. That's only 0.4 of a watt. Call it half a watt. I don't know if the voltage changes or if it's a steady 20. Let's see what's on the other one. I think it's a steady 20. How hot do they get? Yeah, look, I've got no complaints about them. I think what I'm going to do is I'll go to JCar tomorrow. I'll do it, yeah, just to get this finished. I'll get these 2.2K resistors in the bigger package that I was showing you. I will stand them off the board a little bit. I will change these to 1Ks with these, just to show you how hot they are. I reckon it would make my spit boil. You see that? Can you see that on camera? That is bubbling and burning into a white, hard substance. Oh man, that is ridiculously hot. Does anyone want to see how hot it is? I'm not kidding. I'm not kidding. This is insanely hot. I just want to show you guys so you understand why I'm doing this. Because I do want to keep everything as original as I can in here, other than getting more performance out of it. But at the same time, I'm not going to have... I mean, it feels like it's somewhere around 100. Like, it's really bad. I'm just going to get some thermal compound so I can get my temperature probe that I made. When I say made, I've just cut the nichrome and aluminum, the chromal and aluminum wires back and twisted them together, covered the end in solder and made a nice little, very small head up. Yes, I know the solder can actually add a third junction to it, but it actually doesn't seem to have an effect. I've trialed this for years. And you get that in the thermal compound. Look at that. Look at the temperature on that. It's climbing. And that's not even coupled that well. That's already at 150. That meter's off by like 6 degrees. That's past 150 now. That's 156. You know why I've been saying ouch and swearing now. So, I'm definitely putting 5 watt resistors in there because that is just unacceptable. By my standards anyway. Your mileage may vary. But for me, no. I'm not comfortable with that. Alright, so I'll move you guys over here. Oh, I'll leave the camera there. I've got to get the boards out first anyway. I'll unplug the boards whilst holding them still so we don't short them out. And then we'll remove the boards. And I'll bring you guys back around here. I'm going to have to move my clip again. Sorry. Right. Okay. And yes, I am aware that that's plugged in and that there is 240 volts on the power switch on the front. I do know that. Because for those that are worrying, you see me wave my hand right close to it. It probably looks closer on camera than what it is in real life, I can assure you. I know it's there and I don't want to touch it. Not that it would hurt me anyway, because I'm standing on carpet on a wooden floor, so the amount of current that's going to go through my... Yeah, it's not going to kill me, but I would feel it. And if I touched both pins, then you'd hear me swear again. Come on. Soldering iron went to sleep. Actually, I'm going to turn my desoldering gun off. I'm just going to clean the tip. Turn that off. To save the element in it. Because the elements go quicker at their 220 volt elements, and I've done the math on this. I've checked the resistance of the element and the wattage rating of it, and it is actually designed for 220 volts. So even though it's controlled by a triac which fires pulses at it, when you first turn it on, it is really burning the shit out of it. And I can prove it because if you look in the dark, you can actually see it starting to glow red. So yeah, I think I might have explained this in another video. The reason I don't have it powered off the bucking transformer in my soldering station is purely for the fact that the bucking transformer will change the sine wave. I don't know it's going to change the sine wave so much, but it's going to screw up the power factor or the phase, like the relationship between the voltage and the current, and probably kind of square up the sine wave a bit too, depending on how it's wound and how close the core is to saturation. But my point I'm getting at is you can't use a bucking transformer on a transformer that's then powering a... Sorry, you can't use a bucking transformer in series with a triac based circuit, basically speaking. Not in series, you know what I'm trying to say. You can't use a bucking circuit with a triac based circuit. It screws up the 0 point crossing, and the triac will just be firing at random intervals, which I can assure you don't want. I'm getting these up a little bit higher. I don't want to go too crazy on it, but I do want them just up a bit. About that, you know. Obviously it's not like it's a high frequency circuit or anything, but still a power supply. You don't want to go adding inductance to everything. I'm just going to flare these in properly now, because the solder on these pins is not very solid. is it that oxidized? I can't solder to this standoff. Like barely. Yikes, it's getting a bit too hot for this old board. I guess it's soldering to the inside where the solder was, so I'll just put a bit more on there. That'll have to do. Yeah, none of them are pretty. It's like a little slot there, you can see there. And the solder inside the slot is fine, but it won't stick to the top of it. The solder's that standoff sort of pin thing is heavily oxidized. Like I said, don't worry, I'll come back and reflow them properly. I'm just trying to get them in place. So I've got that extra bit of clearance to stand them off the board, basically. Well, that's those standing off the board a bit. Trying to keep it away from the diode and the capacitor, if anyone's wondering. Anyways, what else? What else do I want to do? I think we'll take these 4 diodes out. I'll just go get some replacements. And for those that are wondering, well, they just went in 4007s, but for those that are wondering, what I'll do with those other 3 diodes that I take out, all of them, the other 3 I'll actually put in a separate drawer because they may have some really good properties to them, like they might make a really good varactor diode, for example, you know, and prove useful in some special circuit I'm designing in the future for myself. You just never know. And I turned the desoldering gun off. Alright, well, I'll pause the video, I'll pack up a bit whilst I wait for that to heat up. Alright, so that's heated up. Yeah, I did one of the wrong pins. Tell you what, I bloody warm one thing up and something else goes to sleep. You know what else I'm going to reflow? Where those 1K resistors that were running at 150 degrees Celsius were. I've just noticed where they solder into the board. Well, it's probably in the way, isn't it? But there is what do you call it? Crusty looking solder. I wasn't supposed to take solder off that pad. Where's the other two? So it'll be these ones. It's got to be really gentle with these pads because they rip really easily. Now, these do not face the same way each, so I'll just mark. Right, that solves that problem. All good diodes, just not the same diodes. Alright, I'm happy with that. I'll put them two in first. Right, that's those two done. That's those two. You beauty. Alright, so I'm happy with the diode situation now. Happy with the resistors apart from the ones I'm going to get from JK and replace. Yes, these ones get warm, but they're not ridiculous. These ones are ridiculous and they're swelling up and they're about to go open. An increase in value or whatever you want to call it. Actually, you know what? I wonder how hot those 1 ohm resistors get. You know, there's a good chance the board's not charred to a toast there. If those are the shunt resistors for the output, I wouldn't be surprised if they actually get fairly warm. Well, let's do the math on that. Hold on. One moment. 32 volts. 1 amp. Going through 1 ohm. What just happened there? What? Dude, it's 1 amp going through. Oh, I know what I did. 1 amp going through a 1 ohm resistor. 1 volt, 1 watt. Okay. Alright. Yep. I'll just move that a little bit away from that diode. Try and move the diode away from the resistor a bit more. Don't want to bend the resistor too much and crack it. Putting tension on it. Alright, I'm happy with that. Move this diode away too. Alright. So you know what I'm up to now? There are a total of 1, 2, really? Are they different diodes or the same diodes? I can't read all the way around the package. I'm gonna have to lift a couple. Alright, well. The reason it's confusing is because I see some say OA200 and then I see BZY88, but then I also see 88 on this diode and I imagine it says BZY after it, but below it says C3V6, which makes me think it's a Zener, but then that would mean that that's a Zener, that's a Zener, that's a Zener, that's a Zener too, so well, it says BZY88C10. Okay. BZY88 must just be like the brand and batch or some shit. And C10 must be the diode and OA200 must be something else and C3V6 must be the Zener. So okay, well it looks like there's a 3.6 volt Zener there and a 3.6 volt Zener there. And it looks like there is a 5.1 volt Zener there and there. So let's lift those. Oh yeah, that's a clamping diode for the inputs on the op amp. Fair enough. I think it is anyway. Alright, well, let's take off. I'll start on this board first. I want to lift one leg of each Zener and measure them out of circuit. Now, I know what some people might be thinking, hold on a minute, it's a Zener diode, it conducts in both ways, 0.6 volts one way and the Zener voltage the other way. That's true, but if it's open circuit, well, I'm going to stick 40 volts. I don't need a milliamp or whatever, but that's going to get blasted up the rest of the circuitry, op amp inputs and all sorts of stuff, and we don't want to do that. I might have done that in the last video. Alright, for this cheap tool comes in really handy because it's got a specific Zener tester that does up to 40 volts. Healthy diode in one direction. This is the Zener direction now, so whoops. 3.3. And it's 3v6. Well, I'm just going to measure this other one just for the Zener voltage. I just want to see if it's the same 3v3 that comes up, because if it is 3.1, I'm going to just see, I've got heaps of Zeners. If I've got new ones, I'm just going to swap them out. I don't like that. I'll be back in a sec. Alright, I don't actually have, I've got 3.3s, I've got no 3.6s. So what I'm going to do is I'm going to get my power supply, a constant current limited power supply. And I'm going to bring over some power. Let's see. Here's what I'll do. I'll put my meter here so you can see it. I'll put my power supply in the meter. And we'll come over here and we'll set the current at 10 milliamps. And we'll set the voltage at 5 volts. And turn the output on. Probably help. Now, where are my test clips? Well, that's interesting. Might not be enough current at 5 volts. Let me just turn the voltage up a bit. That's interesting. I think these Zeners may have a problem. Every so often when I move the voltage around, it flickers close to it. That's at 10 volts, 10 milliamps. Let's see what the other one does. Yeah. Let's see what it does at 1 milliamp. Well, that's 5 milliamps. These Zeners are very unstable. I realise there's no capacitor across it. Let's add one of those. Really? These Zenas don't seem to be good to me. I'm just going to grab one of my 3.3 volt Zenas and see how it behaves underneath those circumstances. So it wants more current, like what I thought. We go back to 10 milliamps. 10 volts. I think 2.5 volt Zenas. Okay, so that power supply's just got too much noise on it. And I don't have a capacitor across my Zena. That's fine. That's a 1 in 4728. Let me just see what voltage that's supposed to be. I thought it was 3.3. It is 3.3. 1 watt. Okay. Oh, I'm hitting the wrong button. Alright. Yeah. Around 100 milliamps. I'm getting the 3.3 volts. Let's try and test these ones at that current and see what we get. I'm having a real trouble believing that these are good. And they don't measure exactly the same either. Tough call. I think I'm going to replace the Zenas. Well, not think, I'm just going to do it. I wonder what the current is that they've set up for the Zena. Well, I'll come back to that. Let's have a look at the Zenas on this board. No, I just desoldered the wrong diode. So I guess that explains why there's an air hole around it. It's to try and keep it cool. Because that's essentially this power supply's reference is just a bunch of Zener diodes. 4 Zener diodes. These are supposed to be 5.1. 5.5. Let me turn my current back down. That's at 10 milliamps, which is 10 volts at 10 milliamps. And that's behaving a little bit better. I'd say they're good, surprisingly. Well, I mean, it's not like that off by an order of magnitude, but I'm still going to change them with new ones that are going to be a lot closer and more high tolerance. So I'll add that to my list for J-Car tomorrow. 5.1 volt Zenas I've already got, I know that. 3.3s, sorry, 3.6s I don't have. I only have 3.3s. Alright, well what else can we do? I wasn't going to do the op amps today. I was going to leave that for the third and final part. I was really hoping to get everything else finished today, but so I guess Zener diodes, the 2.2k resistors, and the op amps will be done tomorrow. I can't really do much more now. I've done everything that I can do with what I've got here, so I'll leave this sitting off to the side. I'll put my Zener and my cap away, and these diodes, and I will see you guys tomorrow. Thanks for watching. See you all. Take care. Bye.